Satellites are powerful. They see the big picture. They watch clouds from space. They track storms across oceans. But there is one problem. Satellites mostly see the tops of clouds. They do not see clearly inside them. A cloud might look large and dramatic from above, but it may not be producing much rain. Another cloud may look smaller, but be releasing heavy rain underneath. From space, that detail can be hard to measure. To understand what is actually falling from the sky, meteorologists need something closer to the ground. They need a tool that can look inside the cloud. That tool is radar. Radar does not wait to receive signals. It sends its own signal out and listens for what comes back. Radar works in a very direct way. It sends out short bursts of energy into the sky. Think of it like a flashlight, but instead of light, it sends radio waves. These waves travel outward in a wide beam. If nothing is in the air, the signal keeps going. But if the waves hit something, like raindrops, snowflakes, or hail, part of that signal bounces back. The radar station then listens carefully. By measuring how long it takes for the signal to return, the system calculates how far away the rain is. It repeats this again and again, scanning the sky in all directions. Within minutes, a full map of precipitation appears. Rain shows up clearly on radar because water reflects energy well. When the radar wave hits a raindrop, some of that energy scatters back toward the radar station. The more raindrops there are, the stronger the returning signal becomes. Light drizzle produces a weak return. Heavy rain produces a strong one. Large drops reflect more energy than small ones. That is why radar maps use different colors. Those colors represent signal strength. Strong return means heavy rain. Weak return means light rain. What you see on a radar screen is not a photograph. It is a picture made from echoes. Radar does more than show where rain is. It shows where it is going. Each scan is repeated every few minutes. When meteorologists compare one scan to the next, they can see movement. If the rain shifts east, they know it is traveling east. If the system speeds up, they measure that too. By tracking this motion, forecasters estimate when rain will arrive and how long it may last. This is how weather apps can say, rain starting in 20 minutes. Radar turns weather into motion. It shows speed, it shows direction, it shows change, and change is what forecasting is all about. Radar can detect more than rain. Snow reflects signals differently than rain. Hail reflects even more strongly. Hailstones are solid and dense. They bounce back stronger echoes. Snowflakes are lighter. Their signal is softer. By studying the pattern and strength of the return, meteorologists can estimate what type of precipitation is falling. This matters. Rain and snow affect roads differently. Hail can damage cars and buildings. Knowing what is falling is just as important as knowing where it is falling. Modern radar can do something even more powerful. It can measure motion inside the storm. When raindrops move toward the radar, the returning signal changes slightly. When they move away, it changes in the opposite way. This small shift allows radar to detect wind speed and direction. This is called the Doppler effect. It helps meteorologists see rotation forming inside storms. Rotation can be a warning sign for dangerous weather. Without Doppler radar, wind inside storms would remain invisible. Now, forecasters can see movement even when clouds block the view. Radar is powerful, but it has limits. Because the Earth is curved, radar beams rise higher as they travel farther away. This means distant rain near the ground can sometimes be missed. Mountains can block signals. Buildings can interfere. That is why radar networks use many stations working together. When one radar cannot see an area clearly, another may fill the gap. Radar works best when combined with satellites and ground observations. Each tool supports the others. Radar lets meteorologists see rain in real time. It reveals where precipitation is falling, how strong it is, and where it is moving. It even shows wind inside storms. But rain is only one part of weather. Temperature controls whether rain turns into snow. It influences storm strength. It shapes wind patterns. In the next episode, we will explore how temperature is measured accurately, from the ground all the way up into the sky. Thanks for watching. If you enjoyed this video, please subscribe to the channel. You can also follow us on the platforms on screen for more simple, easy to understand videos about the technology behind everyday products and systems.